All right, today we're going to take a look at the topic 2 review, chapter 2 review. It starts off with a vocab review, things that you should know as far as vocabulary. Don't forget, in Canvas, there is a solutions manual that will walk you through each of these and tell you the answers to all of these. So make sure that you're familiar with what all these terms mean, as well as kind of the definition of them. Check that out in Canvas. So lessons 2.1 and 2.2, it looks like they went ahead and hodgepodged it all into one review. And it's because they're super similar. They're both dealing with parallel lines and transversal and the relationships that those two things form. So the quick review. When two parallel lines are intersected by a transversal, the angle pairs that are formed have special relationships. These angle pairs are either congruent or supplementary. So that's key. Everything that they've taught you so far in chapter 2 either means that the two angles that are paired or that are formed are congruent, they're equal to each other, or that they're supplementary. They're like a linear pair. They form a straight line. They add up to 180 degrees. So for example, just a couple of examples down below. Angles that are congruent, that are equal to each other, are angles 1 and 4. Those are what they call vertical angles. Vertical angles are always equal to each other. 2 and 3 are another example of vertical angles. Other angles that are congruent are angles 1 and 5. Those are congruent to each other. They're equal. They're corresponding angles. 2 and 6 are another set. Supplementary angles are angles that add up to 180 degrees. So for example, 1 and 2. If you notice, they both lie on a straight line, right? Angles 1 and 2 form that straight line. So those are supplementary. They add up to 180. Other ones are like 5 and 7, right off that transversal. You see that 5 and 7 form that straight line. But other ones might not be as obvious as just looking and seeing a straight line, like angles 4 and 6. Those are actually supplementary as well. They add up to 180 degrees. They're what they call same side interior angles back in, lesson 1 or 2.1. So those are same side interior angles, but those are also supplementary. They add up to 180 degrees. So they're saying which angles are supplementary to angle 3. So basically, what angles will add to angle 3 and add up to 180 degrees? So I think angle 1, right? Angles 1 and 3 are supplementary. They add up to 180 degrees. Angle 2 and 3, those are vertical angles, so they're congruent. They're equal. They will not add up to 180, or they may, but in this case, it's not guaranteed. 3 and 4, those are supplementary. Those are linear pairs. They form a straight line. So those add up to 180. Kind of like we were talking about earlier, same side interior angles, 3 and 5. Those two will add up to 180 degrees as well. 3 and 6 are opposite interior angles. So those are congruent. They're equal to each other. So those are not supplementary. 3 and 7 are actually corresponding angles. So they're the same. They're congruent. They're equal to each other. And I think 3 and 8 are the other pair of supplementary angles. Kind of like earlier, if that's hard for you to kind of visualize 3 and 8, just remember that 3 and 6 are the same. They're equal. They're congruent to each other. So if 3 and 6 are the same value, well, 6 and 8 are supplementary, right? They form a straight line. So knowing that 3 and 6 are the same, 6 and 8 are supplementary, that means 3 and 8 are also supplementary. Use this figure. So you'll notice that our figure has some drawing on it, and that is because I already filmed this lesson once and the audio was off of the video, and I didn't want to give you guys a crappy video to watch. So I'm not sure what's going on with that. So if you see some pencil marks on here, just kind of ignore them. I'm just re-recording this video. So use this figure to answer 8 through 10. So suppose L is parallel to M. You can see that up above. What's the measure of each angle if the measure of angle 2 is 138? So if we know that that is 138, what's the measure of angle 1? Well, 1 and 2, that kind of goes back to the example they just talked about. Those are supplementary angles. They add up to 180 degrees. Again, because they both lie on that straight line, right? So if I add angle 1 to angle 2, it forms a straight line, 180 degrees. So if I know that angle 2 is 138, well, all I have to do is subtract that from 180. 180 minus 138 is 42. So I know that angle 1 is 42 degrees. What about angle 3? Same idea. If I know that angle 2 is 138, angles 2 and angle 3 also are supplementary. If I add the two values together, it forms that straight line, which is line L. So knowing that, if I add those two together, it adds up to 180. I can do the same thing I did with A. If those two lines or those two angles add up to 180 degrees, and I know that measure of angle 2 is 138, well, 180 minus 138 is 42 degrees. Now you might be thinking, that's the same thing as A. Are you sure you're not messing up? Well, I don't think I am, and let me explain why. If I told you in A that angle 1 was 42 degrees, look at the relationship between 1 and 3. Those are what they call vertical angles. So they're always going to be congruent. They're always going to be equal. So without even thinking about angles 2 and 3, if I found out that angle 1 was 42 degrees, I should automatically know that angle 3 is 42 degrees because of vertical angles. And then what about angle 4? If the measure of angle 2 is 138, we'll take a look at what you got here. You got two parallel lines, L and M. This is your transversal. So what I have are alternate interior angles, which are congruent. They're equal. So the measure of angle 4 would have to be 138 as well, because they're congruent to each other. So those relationships between all these different angles, when you have a set of parallel lines and a transversal, make sure you're comfortable with that. Make sure you're comfortable when they're equal. Make sure you know when they're supplementary, when they add up to 180 degrees. That's important. Number 9, if the measure of angle 1 was 3x minus 3, and the measure of angle 5, which is right there, is 7x plus 23. What's the value of x? So the first thing we have to think of is what's the relationship between these two angles? It looks like they're same side exterior angles, right? So they're both on the same side of the transversal. They're both kind of on the top of the transversal. And they're both on the exterior parts of those parallel lines. So same side exteriors, those add up to 180 degrees. Those angles are supplementary. So what I can do is I can take the measure of angle 1. I'm just writing this down below a little bit, but I'll put it up on the book here in just a second. I'm kind of out of space on my desk here. The measure of angle 1 is 3x minus 3. The measure of angle 5 is 7x plus 23. So I'm just kind of rewriting down the information they gave me. Knowing in that picture that those two are same side exterior angles, I know that if I take those two angles and I add them together, they should add up to 180 degrees. So 3x minus 3 plus 7x plus 23 equals 180. Now I just use some algebra, solve for x. 3x plus 7x is 10x. Negative 3 plus 23 is 20. If I solve my equation, I'm going to subtract my constant. So subtract that 20 from both sides. I get 10x equals 160. Now I'm going to divide by that coefficient. So I get x equals 16. So let me make sure I'm answering the question they're looking for. What's the value of x? Perfect. So x equals 16. Number 10. The transversal that intersects two parallel lines forms corresponding angles with measure of angle 1 equals 3x minus 7, and the measure of angle 2 equals 2x plus 12. What's the measure of each angle? This question, I think, has a typo in it. So it depends on what you're looking at. Up here at the top, it says that this example, or that these problems 8 through 10, you should be using this figure. But if you look, the measure of angle 1 and the measure of angle 2, those two are supplementary, right? They add up to 180. They're not corresponding like they're telling you in the problem. So we'll take a look at it in both ways, both if it's corresponding and if they're supplementary, because I don't know what they were trying to get at here. Because it's stating that they're corresponding angles, but they're not. They're supplementary. Corresponding angles are angles that are equal, angles that are congruent. So for example, angles 2 and angle 5, those are corresponding angles. Okay. So let's look at it, assuming that maybe they just have the typo. Let's use measures of angle 5 and angle 2. So instead of angle 1 and 2, let's use 5 and 2, because then they'd be corresponding angles. So the measure of angle 5, we'll call 3x minus 7. The measure of angle 2, we'll say 2x plus 12. Again, just assuming that they accidentally put 1 instead of a 5, because now they are corresponding angles. If they're corresponding angles, you know they're congruent, that they're equal. So what I'll literally do is just actually set them equal to each other. So if those two things are equal, 3x minus 7 equals 2x plus 12. So now I just solve. I think I'll subtract 2x from both sides. So I get x minus 7 equals 12. I'll add 7 to both sides, and I get x equals 19. Again, let me make sure they're looking for x here. What's the measure of each angle? So I'm glad they asked that, because if you said 19, you'd be wrong. The measure of 2, the measure of 5 is not 19 degrees. They're saying that x is 19 degrees. So what I would have to do, since these two equations, since these two things are equal, it doesn't matter which one you pick. You could pick angle 5 or you could pick angle 2. It's going to give you the same answer. So what I'm going to do is I'm going to go back and plug it into angle 5. So 3x, measure of angle 5, equals 3x, x is 19, minus 7. 3 times 19 is 57. So 57 minus 7 is 50. So really important you understand what they're asking you here. They're not asking you to solve for x. They're asking you for the actual angle. So once I get the value of x, then I can plug that into either angle. It doesn't matter which one. Since they're equivalent, it doesn't matter. Plug it into either one and you'll get 50. Now, thinking about it the other way, assuming that the picture is maybe wrong, let's go ahead and just assume that these are corresponding angles, that let's assume that they are supplementary angles. Maybe they screwed up and they wanted to put supplementary here for angles 1 and 2, because up here in the picture, they are supplementary. They add up to 180. So that's very similar to number 9. If they're talking and they want to show that these two angles are supplementary, I'll say that the measure of angle 1 equals 3x minus 7. The measure of angle 2 is 2x plus 12. And instead of corresponding angles, if they wanted to show that these were supplementary, that means that they would have to add up to 180. So just like in number 9, I would take each angle and I would add, I didn't mean to put an equals there, I would add them together, and they should add up, if they're supplementary, to 180 degrees. 3x plus 2x, that is 5x. Negative 7 plus 12 is 5. Now I'll solve for x, so subtract that constant from both sides. 175. Divide by the coefficient, 35. So I get x equals 35. Again, I already know they're not looking for x, so I know that I'm going to have to go back up here and plug that value in to make that true. What is the measure of each angle? So in the last example, the angles were equal because they were equivalent, they were congruent, they were corresponding. So it didn't matter which equation I plugged it into, it's going to be the same. In this case, that's not the case, right? These two angles are different measurements. So I need to plug that in and check. So I'm going to say the measure of angle 1. If x is 35, I'll have 3 times 35 minus 7. 3 times 35 is 105. 105 minus 7 is 98. So the measure of angle 1 would be 98 degrees. And then the measure of angle 2, I'd use that equation or that function, 2x plus 12. So 2 times 35 plus 12. 2 times 35 is 70. 70 plus 12 is 82. And just like I said earlier, these are supplementary. 98 plus 82 is 180. They add up to 180. Then the last thing we got to look at for our review is 2.3. Remember, we're skipping 2.4. We're not doing it, so it's not going to be on the tests, and we're not going to spend time in the review doing it as well. It starts off by saying the interior and exterior angle measures of a triangle have the following properties. These were the two big ideas from lesson 2.3. The first one being if you add up all the angles inside any triangle, it's always going to add up to 180. So if you look over here, 11 through 14, you get a bunch of different shaped triangles, but it doesn't matter the shape of your triangle. All of these angles on the inside will always add up to 180. If it doesn't, either you messed up or it's not a triangle. One of those two things have to be true. The measure of each exterior angle of a triangle equals the sum of the measures of the two corresponding remote interior angles. Here's a little picture of what they're talking about, but the big idea here, if you take a look at number 12, it says that the measure of x is going to be equal to the sum, so you have to add these things, the sum of the two opposite interior angles. So that's how it works. The measure of this exterior angle is going to be equal to the sum of the two opposite, so you want to go to the opposite side, the two opposite interior angles. So I just add those together and it'll give me x. So here's an example right below it. What's the measure of angle 1? So there's angle 1. So the measure of angle 1, if I go to the opposite side, it's going to be equal to the sum of those two angles, 36 and 127. So 36 plus 127 is 163. So angle 1 is equal to 163. 11, what's the value of x in each figure? Again, this is a triangle. Inside of a triangle, when I add all three of those things up, it should add up to 180. So it's going to be 50 plus 74 plus x equals 180. 50 plus 74 is 124. So if I subtract 124 from both sides, I'm going to get x equals 56 degrees. 12, so 12 is looking at that second property, that exterior angle, x, is going to be equal to the sum, so I'm adding these two things together, right, to the sum of the two opposite interior angles, so 72 and 63. 72 plus 63 is 135. So x has to be 135. For 13, same idea as 12, but you just have a different piece of missing information. Instead of missing that exterior angle, now you're missing an interior angle. Set it up the exact same way. So just like I was talking earlier, that exterior angle, 152, is going to be equal to the sum of the two opposite interior angles, 103 and x. So the setup is exactly the same. Nothing different. Now I just have to do a different step to solve. So in this case, I want to get x by itself. So I'm going to subtract 103 from both sides. And what do I get? 49 equals x. So that was number 13. And then number 14, let's take a look. Again, very similar to 13, same idea. Take that exterior angle, set it equal to the sum of the two opposite interior angles, x and 40. So in this case, I just subtract 40 from both sides, and I get that x equals 26 degrees. Ooh, one last problem. Make sense and persevere. During a storm, a tree is blown against a building so that it forms a triangle with remote interior angles of 90 and 52 degrees. What's the measure of the corresponding exterior angle formed by the leaning tree? So for me, just like in, when you get to this level of sometimes in geometry, sometimes in algebra 2, but definitely pre-calc, you really want to be drawing these things out. Sometimes that's really hard to visualize and make sense in your head. So I like to draw just a quick sketch. It doesn't have to be anything super fancy. So it's talking about a tree leaning against a building. So here's my crappy building. There is my crappy tree, right? Super tall tree with just the little leaves up top. And then there is my ground where everything sits. So of course, right, not a great picture, but it's going to get the idea across on what we're talking about here. So it's saying that the two remote interior angles are 90 and 52 degrees. So I'm going to say that that's 90, that's 52. If you weren't drawing a picture, it wouldn't really matter where those angles are. You could call that 90, you could call that 52 because you're just adding the two things. But since we're drawing a picture, right, the ground meets the side of the building, it looks like a 90-degree angle. So that's why I'm putting that there. And then they're saying, what's the measure of that corresponding exterior angle? So essentially what they're looking for is that right there. Okay. So we know that that exterior angle is going to be equal to the sum of the two opposite interior angles. So 52 plus 90, that's 142. So I know that x is 142 degrees.